All right, 4.2, number 33. So we have f of x equals 2 plus 1 over x. So this is the 1 over x function moved up 2. What's the 1 over x function look like? Well, that's a parent function that goes like this through the point 1, 1. If I put in 1, I get 1. Put in 2, I get 1, 2, I get 1 half. If I put in 3, I get 1/3, 1/4, and so on. If I put a half, I get 2. Put in a third, I get 3, etc. And same for the negative side. So if I have that as the parent function here, and this says move it up 2, so it would look like 1, 2, and it would go up 1 over 1 from there, just like it did here, and curve like that, and go closer to the y-axis up here, and x-axis, and it would be also over 1, 1, go through that point and go like this, and go through a negative 1/2 here and go down like that. So that's 2, and this is 1. This is minus 1. And that's what that looks like. Now, what did they ask us to do? On that one it said graph the rational function using transformation. So I just moved the parent function up 1. Use a final graph to determine the domain and range. So I can use anything for x except 0. All reals except 0. And the range for this function, I get anything out except 2. So it's all reals except 2. Use the final graph to list any vertical asymptotes. Vertical asymptote is x equals 0, the y-axis. And horizontal is y equal to, that's this horizontal line. And there's no oblique because this is just the let's show you how this works here based on the rules. So if I get a common denominator, add these together, I get 2x over x, multiplying by x over x on this, plus 1 over x. Now they have a common denominator, and this becomes 2x plus 1 over x. They're the same degree, so I go by the ratio of the coefficients, 2 over 1, and it's y equals 2. 2 over 1 is 2. So I got that. Okay? That's 33. And then we're going to do 34. 34 has the equation 3 plus 1 over x squared. This is q of x. So this is 1 over x squared. That's a new parent function that you may not be real familiar with. 1 squared is 1. I'm just looking at this part. 1 over 1 squared is 1. 1 over 2 squared is 1/4. 1 over 3 squared is 1/9. And 1 over a half squared is 4. 2, 3, 4 up here. So it doesn't get as fast close to the x-axis as the other one, but or to the y-axis, but it does go faster towards the x-axis. And this is going to be the same thing for negative 1, 2, and 3. I'm going to go through 1 here because negative squared are going to be positive, and it's going to look very similar on this side, symmetric with the x-axis. So domain is going to be We can put in anything except 0. Oh, by the way, I got to move this up 3 to actually get the true picture here. So this moved up 3. 1, 2, 3 is going to be something in here and over here. So the domain is all reals except 0. The range is going to be from 3 up. So range is real numbers greater than 3, or I could say from curved here, from 3 to infinity. That's the y values from 3 to infinity. Can't be 3, but right up to 3. And it said, can we identify the vertical asymptote? That's x equals 0, this line. And can we identify the horizontal? And if you do the degrees here, we get a degree of the numerator greater than the denominator, so it would have been 0, but since it's moved, this one is 0, the degree of the denominator is greater than the numerator, so it's 0, but it's moved up 3, so it's y equal 3 for the horizontal asymptote. And what else did we have to do? I think that's it. Okay. And then we have to do, for folks, 38. 38 says g of x is 2 over x plus 2 squared. Okay. So first of all, x cannot be minus 2. So we have a vertical asymptote at minus 2. X equals minus 2. Minus 2. Negative 2. Horizontal. Okay, since the degree of the denominator is greater than the numerator, then it's y equals 0. Do we have a y-intercept making x be 0? This would be 0 plus 2, which is 2 squared is 4. 2 over 4 is a half. So when x is 0, we get 1/2. So it goes through 0, 1/2. And we have, can we get any x-intercepts? And that would be making y be 0. And a fraction can't be 0 unless the numerator is 0, and 2 can't be 0, so no x-intercepts. So it doesn't cross the x-axis. And that kind of matches. We have a horizontal asymptote of y equals 0. In this case, it doesn't cross it. It could cross, but it doesn't. And then we'll check the behavior near this asymptote. If we put in negative 1.9, negative 1.9, well, this is always going to be positive. This is going to be positive, so it's going to go towards positive infinity. And even if we go on the back side, this is still going to be positive. A little bit like negative 2.1, you could put that in here, we get a negative, but squared is positive. Positive by positive, it goes to positive. And so this has to go something like this. Through that place and like that. Okay. Oh, so what's the domain? All reals except minus 2. And range. So that would go from 0, whoops, not including, 0, height of 0 to infinity. And I gave everything else that asked for it. So that's number 38.